Hi dear students, in this video we are going to learn about developments leading to Bohr model of atom. So mainly in this video we will learn about the wave nature of electromagnetic radiation, right. This is the seventh part of the chapter, structure of atom. Developments leading to Bohr model of atom. Bohr model of atom. Mainly two developments which are leading to the Bohr model of atom is, there is a two developments which are leading to the Bohr model of atom. First one is dual nature of electromagnetic radiation. Dual nature of electromagnetic radiation. Dual nature, that is, one is particle nature, other one is wave nature. Dual nature of electromagnetic radiation, right? Wave nature, particle nature and wave nature. Second development is quantization of energy. Quantization of energy. Quantized energy levels, that is from the atomic spectra, right. So first let us take the first topic, dual nature of electromagnetic radiation. In that, wave nature. Wave nature of electromagnetic radiation. Wave nature of electromagnetic radiation. Earlier times Newton considered light as particles. Newton considered light as stream of particles, which he called it as corpuscles. Stream of particles, that is known as a corpuscles. Later, Young's double slit experiment, that is interference pattern of the light, proved that it has a wave nature. Early times, the Newton, famous scientist, physicist, Newton considered light as stream of particles, which he called it as a corpuscles, right. Then later, Young's double slit experiment proved that light has a wave nature, that is interference pattern of the light, and diffraction proved that light has wave nature, right. So then about the electromagnetic radiation, it has been explained by James Maxwell. The scientist's name is James Maxwell. He explained about the electromagnetic radiation. So any electromagnetic radiation, according to Maxwell, he considered it as a wave, electromagnetic wave. When it is traveling through the vacuum, it will create both electric as well as magnetic fields. Now let us discuss about the wave nature of electromagnetic radiation clearly, right. Students, electromagnetic radiation, the radiation which is associated with the electric and magnetic fields. The radiation which is associated with electric and magnetic fields. Let us assume that the direction of propagation for the electromagnetic radiation is x-axis. Along the x direction, electromagnetic radiation is propagating, right? Then assume this as a z-axis, this as a y-axis. Then along the z-axis, magnetic field component, if it is present, along the z-axis, if the magnetic field component is present, then along the y-axis, electric field component is present. Along the y-axis, electric field component is present, right? So that means the magnetic field component and electric field components are perpendicular to each other, and both are perpendicular to direction of propagation. Students, here the direction of propagation of the wave, electromagnetic wave, is along the x direction. Then along the z direction, if it is a magnetic field component, magnetic field component is oscillating along the z axis, and along the y axis, electric field component is present. Electric field component is present. So the radiation which is associated with electric and magnetic fields, that is known as electromagnetic radiation. And the properties of electromagnetic radiation, let us discuss now. Properties. Electromagnetic waves, in the shortcut I am writing it as EM waves, when traveling through the vacuum, they will create oscillating electric and magnetic fields. Electric and magnetic fields. Both are perpendicular to each other, and they are perpendicular to the direction of propagation. All electromagnetic radiation in vacuum travels with the speed of light. These do not require a medium. Without any medium, they can also travel through the vacuum, right? So next point we will see. In the properties of electromagnetic radiation, all types of electromagnetic radiation constitutes which is known as electromagnetic spectrum. Electromagnetic spectrum. Students, all different type of electromagnetic radiation, they are arranged in increasing order of wavelength, that is known as electromagnetic spectrum, right? So there is one story to learn that energy order or the wavelength order. If it is increasing order of the wavelength, then decreasing of the order of the energy, right? So for that there is a simple story that I will write I will tell the story, along with that I will write the direction, right? So a boy was listening the radio on the terrace. Radio waves, it will come, radio waves. Boy was listening the radio on terrace. He got some disturbance and started watching the TV. He got some disturbance and started watching the TV, right? Then he got some phone call to attend a shop opening party. That is microwaves. Mobile phone, that electromagnetic radiation present is microwaves. Then he is getting ready and then started. He is getting more sweat. Sweating is due to infrared radiation. IR, infrared radiation. And he gone near to the shop, that is which he has to attend the opening party. Then the board of the shop is clearly visible, glowing in the daytime also, because it is made with the neon globe bulb. Next, visible, right? Then after the completion of the party, he watched, the time is 11 o'clock in the morning. Today there is a solar eclipse. Then after that, one of his friend is got affected by UV rays, ultraviolet rays. Then they went to the doctor. Doctor told to take X-ray, right? Doctor told to take X-ray of eye. It is not possible, right? Generally for the order, it is doctor told to take X-ray. And that boy has seen some symbol like this, gamma it is. And he asked the doctor, is there any elections nearby? Then the doctor told, it is not a symbol of any political party, it is a radioactive zone, don't enter into this zone. Then in this we have gamma rays. And after the completion, then the boy returned to his home, and then he again started watching the TV. One movie is coming, that is the Incredible Melting Man. One of the astronauts got affected by cosmic rays, right? So highest energy of in the electromagnetic radiation is cosmic rays, right? We are writing this is a wavelength order. Wavelength is generally inversely proportional to the energy. So highest wavelength is for radio waves. And highest energy electromagnetic radiation is cosmic rays, right? Once again, shortcut I will tell you that boy was listening the radio on the terrace. He got some disturbance, started watching the TV, and then he got some phone call to attend a shop opening party. Started getting more sweat. Sweating is due to infrared radiation. Gone near to the shop. Then board of the shop is clearly visible, glowing in the daytime also, because it is made with the neon globe bulb. And then after that he watched, the time is 11 o'clock in the morning. There was a solar eclipse that day. Then one of his friends got affected by UV rays. Then they went to the doctor told to take X-ray. Then he asked that boy to the doctor, it is any political party symbol like that. Then he told, it is not a political party, it is a radioactive zone, gamma symbol it is present, don't go into that zone. Then he returned to the home and started watching the TV. Some movie is coming, that is Incredible Melting Man. One of the astronauts got affected by the cosmic rays. Students, this is the order of increasing order of wavelength. If it is increasing order of energy, reverse order we can put, right? In the next video, we will discuss about the properties of waves clearly. Thanks for watching.